Today we are going to focus on sample size determination for confidence intervals. This video is about planning before data collection. Instead of starting with a sample and building a confidence interval, we start with a goal and ask how much data we need to collect to meet that goal. Sample size determination is closely connected to confidence intervals. Confidence intervals describe uncertainty. Sample size planning is about controlling that uncertainty before you collect data. The main idea of this video is simple. If you want a confidence interval to be reasonably narrow, you need a sufficiently large sample. Sample size calculations help you decide how large that sample needs to be. This type of question is different from the earlier videos. In earlier videos, the sample size was given and the confidence interval was the result. In this video, the width of the confidence interval is part of the goal, and the sample size is the unknown. Sample size determination always begins with the margin of error. The margin of error describes how far the confidence interval extends from the estimate in either direction. A smaller margin of error means a more precise estimate. A larger margin of error means more uncertainty. When planning a study, researchers often decide how much uncertainty they are willing to accept. That decision becomes the margin of error. Sample size calculations answer the question: how many observations are needed so that the margin of error is no larger than a chosen value at a given confidence level? Just like confidence intervals, sample size calculations depend on whether we are working with a proportion or a mean. The structure of the thinking is similar in both cases, even though the inputs differ. Let's start with sample size determination for a population proportion. Proportion questions come from yes or no situations. The goal is to estimate a population percent with a desired level of precision. Before using software to determine a sample size for a proportion, several decisions must be made. First, clearly define the yes category. The sample size calculation depends on what is being counted as yes. Second, choose a confidence level. Common choices include 90%, 95%, and 99%. Higher confidence levels require larger sample sizes. Third, decide on a desired margin of error. This is how close you want the estimate to be to the true population proportion. For example, you might want the estimate to be within 3 percentage points or 5 percentage points of the true value. Fourth, provide an estimate of the population proportion. This value does not need to be exact. It is often based on prior studies, historical data, or a reasonable guess. If no reasonable estimate is available, a common and conservative choice is to use 50%. This choice leads to the largest required sample size and ensures the margin of error goal will be met. Now let's walk through a proportion sample size example. Suppose a college wants to estimate the proportion of students who would support a new campus policy. The administration wants the estimate to be within plus or minus 4 percentage points at the 95% confidence level. Before opening the software, we identify the key pieces. The yes category is students who support the policy. The confidence level is 95%. The desired margin of error is 4%. If prior surveys suggest that support is around 50%, we can use 50% as the estimated proportion. In the software, we select the option for sample size determination for a proportion. We enter the confidence level, the margin of error, and the estimated proportion. The software then calculates the required sample size. Suppose it returns a value of about 600 students. This result means that to achieve a margin of error of no more than 4 percentage points at the 95% confidence level, the sample should include at least 600 students. If the desired margin of error were smaller, such as 2 percentage points, the required sample size would increase. If the confidence level were increased to 99%, the required sample size would also increase. Now let's talk about why sample size increases quickly when precision improves. Reducing the margin of error requires a much larger sample. Cutting the margin of error in half requires more than doubling the sample size. Precision improves slowly as sample size increases. This is why high-precision studies often require very large samples. Now let's move to sample size determination for a population mean. Mean questions involve measured variables such as time, scores, weight, or cost. The goal is to estimate the population average within a chosen margin of error. Before using software to determine sample size for a mean, several decisions must be made. First, confirm that the variable is quantitative and measured with units. Second, choose a confidence level. Third, decide on a desired margin of error. This margin of error must be stated in the same units as the data. For example, you might want the average commute time to be within 2 minutes or the average cost to be within $10. Fourth, provide an estimate of the population variability. This is usually done using an estimate of the standard deviation. This estimate can come from previous studies, historical data, or a small pilot sample. Now let's walk through a mean sample size example. Suppose a researcher wants to estimate the average amount of time students spend studying each week. The researcher wants the estimate to be within 1 hour of the true average at the 95% confidence level. Based on prior data, the standard deviation of study time is estimated to be about 5 hours. Before opening the software, we identify the pieces. The variable is quantitative. The confidence level is 95%. The desired margin of error is 1 hour. The estimated standard deviation is 5 hours. In the software, we select the option for sample size determination for a mean. We enter the confidence level, the margin of error, and the estimated standard deviation. The software calculates the required sample size. Suppose it returns a value of about 97 students. This means that to estimate the average study time within plus or minus 1 hour at the 95% confidence level, the sample should include at least 97 students. If the desired margin of error were smaller, such as half an hour, the required sample size would increase substantially. If the variability were larger, the required sample size would also increase. Now let's discuss an important difference between sample size calculations and confidence intervals. Sample size calculations are based on planning assumptions. The estimated proportion or standard deviation used in the calculation may not be exact. After data are collected, the actual confidence interval may be slightly wider or narrower than planned. Sample size determination helps you plan responsibly, but it does not guarantee an exact margin of error. Now let's talk about how software supports sample size determination. Statistical software does not decide what margin of error is acceptable. It does not decide what confidence level is appropriate. Those are decisions made by the researcher or decision maker. The software uses the values you provide to compute a required sample size. Different software may label inputs slightly differently. For proportions, you may see labels like estimated proportion, p-hat, or anticipated proportion. For means, you may see labels like estimated standard deviation or sigma. These labels all refer to values you supply to represent expected variability. The output of a sample size calculation is usually a single number. This number represents the minimum sample size needed. In practice, researchers often round this number up and collect slightly more data to allow for missing or unusable observations. Now let's summarize the process for sample size determination. For proportions, define the yes category, choose a confidence level, choose a margin of error, and provide an estimated proportion. For means, confirm the variable is quantitative, choose a confidence level, choose a margin of error in the same units as the data, and provide an estimated standard deviation. In both cases, enter these values into the software and interpret the output as the minimum sample size required to meet the precision goal. Sample size determination connects confidence intervals to study design. Instead of reacting to uncertainty after data are collected, it allows you to plan for uncertainty ahead of time. The software performs the calculations, and your role is to choose reasonable inputs and explain what the resulting sample size means in context.